Hi everyone, let's get straight into some fluency then. So the past few days we've been looking at using our number facts to 10 to help us really understand some related number facts to 100, and now we're looking at number facts to 20. So yesterday we used the number fact 8 plus something equals 10. What is our missing number, our missing addend from this equation? Well done if you said that it is 2. Fantastic. So yesterday we looked at 8 plus something equals 20. So we didn't have this 10 here. That 10 there was missing. It was 8 plus something equals 20. But now that extra 10 is there. So this equation has changed from yesterday because now our first addend also has this extra 10. So thinking about what we learned yesterday then, we're trying to make 110 here. And with this equation, we're trying to make 2 10s. Now, that's what's changed between this and this. So this is 110 and this is 2 10s. Now let's have a look at that first addend. Well, that first addend is 8. So over here, you can see that if I start with 8, what do I need to add to make 10? You can see that I need to add 2 more. Now, if we look at the addend on this number here, you can see that I also am starting with 8 ones, but I also have this additional 10 here that this number didn't have. So there we go. I'm starting with 110 and 8 ones. So to complete my second 10, what do I need? That's right, I need 2 again here, and I can fill that in there. So yesterday we noticed that if our starting number here didn't have this 10 on, that extra 10 in 20 has to go here. But now we're learning that if our first addend has this extra 10, then this is just about completing the ones to make the remaining whole 10. Can you see that there? So 8 add 2 makes 1 whole 10, and then that extra 10 is now there. Why don't you have a go at pausing the video and completing the questions on the right using the number facts on the left to help you. When you're ready to go through the answers, play the video again. Fantastic, well done for having a go. So if I know that 5 plus 5 equals 10, then 15 plus what equals 20? Well, I know that 20 has got 2 10s. I've already got 1 10 here, so the number that I need must bond with my 5 ones to make my second full 10. So I know that 5 plus 5 makes 10, so that means that I'm missing 5. So if I know that 6 plus 4 is 10, I know that 16 plus something equals 20. Well, 20 is made up of 2 10s. I've got one of my 10s here, so whichever number goes here must bond with my 6 ones to make that other full 10. So the number that's missing is 4. I know that 7 plus 3 equals 10, so I also know that 17 plus 3 equals 20. I know that 8 plus 2 equals 10, so I know that 18 plus 2 equals 20. I know that 9 plus 1 equals 10, so I know that 19 plus 1 equals 20. I know that 4 plus 6 equals 10, so I know that 14 plus 6 equals 20. Well done if you got those right. And just building on from the stuff that we've been looking at as well over the last couple of days, using now this number fact to say that we know our number bonds to 10, both in addition and subtraction form. our number bonds to 100 in both addition and subtraction form, our number bonds to 20 when our first addend has the 110, and our number bonds to 20 when our first addend does not have the 110. Okay, so today we're going to do something a little bit different. We're going to do a bit of an investigation into symmetry. So I want you to have a look at all of the shapes that you can see here. What do you know about all these shapes? What would you call all of these shapes? If you can't quite remember, have a look at the word map to help you. Maybe count the sides of each shape. Maybe count the vertices. Do all these shapes have the same size? Do all these shapes have the same number of sides? Do all these shapes have the same number of vertices? Are all these shapes the same? Well, I know that they are pentagons. Well done if you managed to work that out. I know that they are pentagons because they all have 5 sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. I know that they are all pentagons because they all have 5 sides, and also that means 5 vertices as well. So the reason that we have so many different types of the same shape is because some of these are irregular and only one of them is regular. There we go, I've just got rid of this middle one because it was confusing us. So looking at these words then, and these are words that we have talked about very briefly before. What do those words mean? If a shape is regular, remember we've only got one type of regular pentagon, whereas we've got all these different types of irregular pentagon. What does the word regular mean? If a shape is regular, maybe if I do this, it might jog your memory. There you go. What does regular mean? Well done if you had a guess. So regular means that all of the sides in my shape are the same length. And also the space here inside our vertices, these are called angles. These are also the same. So you can see, let's take this shape, for example. This has got some very, very wide angles here. But also some quite narrow ones there. So you can see that some of these are different sides. It's got some short sides and it's got some long sides, but in our regular pentagon, they are all the same size. And you might also notice that that then means that whichever way I turn my pentagon, it will look the same because all of those sides and those vertices are identical. So let's recap what we learned about symmetry yesterday. A line of symmetry splits a shape exactly in half. Well done if you said that. So a line of symmetry splits a shape exactly in half. And now what we're going to look at is we are going to have a look at some regular shapes. Now, if a shape is regular, it means all the sides are equal or the same. Well done if you said that. So what we're going to investigate is the number of lines of symmetry within regular shapes. So this is a regular 3-sided shape. What do we call a 3-sided shape? That's right, we call it a triangle. Now what I'm going to do is I'm going to draw a vertical, whoops a daisy, I'm going to draw a vertical line of symmetry over here on our triangle. Now this triangle is a special type of triangle. It's a regular triangle. That means all of our sides are the same length. So it's got one line of symmetry. So now I'm going to rotate it onto its second vertices here and put it there. Is that a line of symmetry? Yes, it is. So now we can say that it has got two lines of symmetry, because before, when this angle was at the top, then I halved it and that was one line of symmetry down the middle here. And then when I rotated it and now this vertex is at the top, then I halve it down here. And we're going to turn it one more time. Let's have a go. Now our third vertex is at the top. Let's line it up. Is that also a line of symmetry? Yes, it is. It splits our shape exactly in half. Now, what we did is we just worked out that if I put my line of symmetry from one of my vertices down to the middle of the opposite side, that will be a line of symmetry. So in this triangle, in this three-sided shape, we've noticed it's got 1, 2, 3 lines of symmetry. So a regular triangle has 3 sides, 3 vertices, and 3 lines of symmetry. Let's have a look at our square then. So a square is a regular quadrilateral. This means it has 4 sides. So a line of symmetry splits a shape exactly in half. So let me get my line of symmetry. Remember, a line of symmetry can go in any direction. It can go vertically, it can go horizontally, and it can go diagonally. So we can see that it has got one line of symmetry. Is that all the lines of symmetry in a square? Hopefully you will remember from yesterday's lesson that it has many more. So we also know that we can put our line of symmetry horizontally in a square like this. But what's also special about a square is that we can do it from the opposite vertices like this. So a line of symmetry splits the shape exactly in half. A regular square has, or a regular quadrilateral, because all squares are regular, has 4 sides, 4 vertices, and 4 lines of symmetry. You can see that here, 1, 2, 3, 4. Maybe you're starting to notice a pattern. Let's have a look. So what shape is this? Can we remember? It's got 5 sides and 5 vertices. So it is a pentagon. Well done. So let's look for our lines of symmetry. So let's try vertical. There we go. Now the easiest thing to do when you're looking for lines of symmetry is to physically turn the shape around. Now, if you're working from an iPad, that would be a really good tool for you to maybe pause the video and have a go at turning it around. Let's have a go then. So if I turn my pentagon around, well, that's also a line of symmetry. So we can see that would be a line of symmetry. Let's rotate it again. There we go. Well, that's also a line of symmetry. So what we're starting to notice is that every time a vertex goes at the top, we can, just like the triangle, halve it down the middle from the middle of that vertex down to the halfway point of the side that is opposite. So it's got 5 vertices. So for every vertex, I am splitting it halfway down, and you'll be able to see that whichever way I rotate that now, those lines of symmetry have not changed, except for this one, which did by accident. There you go, it's back. Okay, so let's count how many we did. We did 1 line of symmetry, 2 lines of symmetry. Let's go from the vertices, that would be better. So 1 line of symmetry. You can actually remove them, there you go. 1 line of symmetry, 2 lines of symmetry, 3 lines of symmetry, 4 lines of symmetry, 5 lines of symmetry. So a regular pentagon has 5 sides, 5 vertices, and 5 lines of symmetry. So I'm going to skip those. I'm going to ask you to have a go. Now what you've got is you've got a table here with a regular 3-sided shape, 4-sided shape, 5-sided shape, 6-sided shape, 7-sided shape, and 8-sided shape. All of these are regular. That means all of those sides are the same length. They're all equal. So what I'd like you to do is on the line, write the name of each of these regular shapes, write the number of sides, write the number of vertices, and write the number of lines of symmetry. I have on the school website prepared a Word document where you can print out these as well. And like I said, the best thing for you to do really is to rotate that and draw a line on every time from that top to bottom. And then there is also a reasoning question for you to do. So Billy says that this triangle has 3 sides and 3 vertices. So it has 3 lines of symmetry. Is she right? So just because it's a triangle and it has 3 lines and 3 sides and 3 vertices, does that mean it also has 3 lines of symmetry? Well, you might notice from our pattern that a regular pentagon, which has 5 sides, 5 vertices, and 5 lines of symmetry. A regular quadrilateral has 4 sides, 4 vertices, and 4 lines of symmetry. Our regular triangle has 3 sides, 3 vertices, and 3 lines of symmetry. But I'm just going to have a look at this triangle, our regular triangle, and compare it with this triangle here. Well, let's move this back that way around. There we go. So you might notice that if I turn this triangle around, well, we already know with this one because we already did it. If I turn this triangle around, it looks the same whichever way I turn it. Does this triangle look the same whichever way I turn it? Does that look the same? No, that looks different now, doesn't it? And that's because it's got some long sides and some short sides. So all these sides are not equal. So this triangle is not regular. So only regular shapes will follow our pattern of having the same number of lines of symmetry as the number of sides and the number of vertices. If a shape is not regular, so let's go all the way back to have a look at our irregular pentagons. If a shape is not regular, then it will not have the same number of lines of symmetry as the number of sides and the number of vertices. Well done, everybody. Really looking forward to seeing the work that you send in. I know this isn't easy, but you're all doing a great job. We'll see you tomorrow for our final maths lesson of the week. Bye now.